feel like an entirely different person.
Good person or bad person? Better or worse?
Better.
All right.
It's cooler. So, did everyone get their homework in? I'm just going to be going over a old exam from 2006. So, it covers pretty similar concepts to what's going to be on your exam. This is one of Weaver's exams, so it's pretty long. It's pretty fond of long exams, but I think we should have enough time to get through it all. So, the first problem is pretty simple. It's just calculating conversion to reactor volume for your mass and energy balances. You have an irreversible reaction. 2A goes to B. It's carried out in the CSTR. The CSTR is at 350 Kelvin. The heat of reaction is 20 kilojoules per mole. There is a heating jacket on the CSTR, and so it's heated with steam at 450 Kelvin. That is way too small. So the overall heat transfer coefficient times the area is 200 watts per Kelvin. And then you have pure A being fed in. And that's at a temperature of 300 Kelvin and a flow rate of 3 moles per second. And then they tell you that it gives you the rate equation is just kCa. And then he tells you that the rate constant follows this equation. CPA is given, that's 40 kilojoules per mole, or joules per mole Kelvin. Huh? Yeah, 10 to the 13th. And then it tells you the vapor pressures of A and B at a certain temperature. So it's 15 bar and 5 bar. And that's at 350 Kelvin, so the operating temperature of the reactor.
Is TA constant?
Yeah, TA is constant.
Okay, so.
Yep. And then delta P is negligible. So that's everything it gives you. And then the first part of the question is to calculate the conversion in the reactor volume when the feed pressure is 2 bar. So the fact that they give you vapor pressures and they tell you feed pressures kind of makes you think that you're going to have to check at least for phase change at some point throughout this problem. May or may not happen. So for part A, everything is below the vapor pressure, so you shouldn't really have any condensation, so it's not really something to worry about for this part. But you just start off with your normal mass balances, so your design equation. Then you know that you write out your stoichiometry, so for A, it's the flow with volumetric flow rate. Yeah, and this is a gas phase reaction too, sorry. So there's no pressure drop, so this term goes to 1. Then you can solve for your epsilon.
Isn't it T naught over T?
Yeah, since it's a denominator, that's what it comes out to be.
One of those.
No, I think it's supposed to be T over T naught there.
No, like,
the other
with respect to
one,
T over
yeah,
T naught,
yeah.
you'll have both knots at the bottom. They're supposed to be flipped. Like, one of them's supposed to be opposite.
Okay,
Yeah,
yeah.
because it's PV equals nRT, so.
Yeah, my bad.
No, I think the P naught's.
Yeah, that's the
Oh,
P
yeah.
The T was right.
Yeah, you're right. All right. So then you just plug this into here for CA. So this is kind of the end form of your mass balance for the first part. So then you can just plug into this equation, sorry, over here, you know your T and your R, so you can find K. When you do that, you get K at 350. Is 6.6 times 10 to the negative 2.
Excuse me?
Yeah.
So, how do you have a pressure that's lower than the vapor pressure to the pure feet of A, when the partial pressure of A at the temperature be 15 bars, you have a mole fraction of 1, so you have to have a pressure of 15 bars. How can you have a pressure of 2 bars? So there's no linear combination of those two pressures that leads you to something lower than 5.
Right, so if it's, I mean, if it's above the vapor pressure, then you're gonna have condensation. So it's below it, it should all be gas.
But like by Raoult's law, right, the partial pressure of the gas is equal to the mole fraction times the vapor pressure. And you can't have a partial pressure of 15 bars if the total pressure is only 2 bars. Like all it's all partial pressure.
That's the saturation.
Yeah.
Saturation pressure base is 1 bar.
Right.
So can you explain to me why that's not happening? I didn't quite follow the logic there.
Yeah, I mean, I don't have a great answer. It makes sense to me. So if you're below the vapor pressure, then it shouldn't be condensed. When you're above it, you get condensation and have a gas-liquid mixture. So, sorry, I can get back to you, but. So just assume for this right now it's all gas. So now you have 2 unknowns and 2 equations to solve, so you have to use your energy balance now. So your energy balance is